and welcome to the session where we would be discussing the exercises of the chapter Reflection of Light at Curved Surfaces. Whatever exercises, answers, diagrams that I discuss with you will be provided to you in the form of either an MS document or a PDF document so that you can go through your answers, match with your answers, and access all the answers easily. So, without any further ado, let us now begin discussing the exercises of this chapter. Question 1. Where will be the image formed when we place an object on the principal axis of a concave mirror at a point between focus and center of curvature? We know this right now. This is a concave mirror. We know that concave mirror produces virtual images only when it goes beyond focus. So right now it is between focus and center of curvature. So as your object goes beyond your center of curvature towards the focus, the image will be formed right beyond center of curvature towards the infinite side, way farther from the mirror, but it will be inverted, it will be real, and it will be magnified, and that means that it will be larger in size as compared to the object. So to give an answer to this, we say when we place an object on the principal axis of a concave mirror at a point between focus and center of curvature, image will be formed beyond center of curvature, and the image that will be formed will be real, inverted, but the size of the image will be larger than the size of the object. This is it. Let us now go to the next question. State the differences between convex and concave mirrors. We have discussed a lot of times while discussing basic definitions of spherical mirrors that convex mirror is a mirror whose reflecting surface curves outwards, while concave mirror is a mirror whose reflecting surface curves inwards. Center of curvature and focus both lie behind the mirror in case of convex mirror. Center of curvature and focus lie in front of the mirror in case of concave mirror. Now, convex mirror is also known as diverging mirror, and concave mirror is also known as converging mirror. Why? Because in case of convex mirrors, light after reflection diverges and does not meet at a certain point, while the opposite is true for concave mirrors. Light after reflection meets or intersects at a certain point or passes through a point. Convex mirrors always form virtual erect and diminished images irrespective of object position. As we discussed, the two object positions for convex mirrors were at infinity and anywhere between infinity and pole, and the image positions that we got were at principal focus and between principal focus and pole, both of them being virtually erect and diminished. Concave mirror, on the other hand, forms different types of images. It depends on the position. You know that if it's at infinity, image will be at focus. If it is beyond center of curvature, it will be between center of curvature and focus. If it is at center of curvature, image will also be at center of curvature. If it is between center of curvature and focus, it will be image will be beyond center of curvature. If it goes beyond focus, then image is produced is virtual. These must always be kept in mind. 3. Distinguish between real and virtual images. For this answer also, you can either use a tabular format to write what the differences between real and virtual images are, what mirrors form them, or you can just use a paragraph to describe the same. It depends on you, or how the question is put, or the number of marks that question contains. So, image formed by reflecting rays of light after they actually intersect at a point is called real images, while image formed when reflected rays are intersected or they are produced behind and then they are intersected, they are virtual images. Real images can be obtained on a screen, while virtual images cannot be obtained on a screen. Real images can be formed by concave mirrors. Virtual images are formed by convex mirrors, except for one exception where a concave mirror forms a virtual image. That is it for this question. Let us now go to the next one. How do you get a virtual image using a concave mirror? You know there is only one condition where concave mirror will produce a virtual image. It is only when the position of object goes beyond your focus and it comes and rests between focus and pole of the mirror. So, to get a virtual image using a concave mirror, the object must be placed between pole and focus of the mirror. The image formed will then be virtual, erect, and magnified. It will be behind the mirror. That is it for this question. Now let us go to the next one. What do you know about the terms given below related to spherical mirrors? So there are terms that are given to you. We have already discussed these terms in our previous sessions. First one is pole. So pole of the spherical mirror is the midpoint of its reflecting surface. It will divide your mirror into two equal halves. Center of curvature of a spherical mirror is the center of the imaginary sphere of which the mirror is a part of or from which the mirror was cut off. Focus. Focus is the point on the principal axis of the mirror at which parallel rays or rays which are parallel to your principal axis actually after reflection meet or appear to be coming from. Radius of curvature. Radius of curvature of a spherical mirror is the radius of the imaginary sphere of which the mirror was a part of or from which the mirror was obtained. Focal length. The distance between pole and focus of a spherical mirror is termed as focal length of a spherical mirror. This is a continuation of the previous question. Principal axis. The principal axis of a spherical mirror is the line that joins your center of curvature to the pole of the reflecting surface. Object distance. Distance measured from pole to foot of object is object distance. It is represented by small u. Image distance. Distance measured from pole to image is image distance, foot of the image, and the image distance is represented by small v. Magnification. We define magnification as the ratio of height of image to height of object. Also, magnification can be defined as negative of the ratio of image distance upon object distance. That is it for question number 5. We only have to write the definitions that we went through in the entire session or those that have been given or provided in your textbook. Let's go to the next question. Write the rules for sign convention. 3 rules of sign convention have been mentioned in the book that you study this chapter from, and those 3 rules are: when giving sign conventions or when giving negative positive signs to the terms in mirror formula, that is focal length, image distance, and object distance, all distances will be measured from the pole. Distances which will be measured in the direction of incident light will be positive, while those that are measured in the opposite direction of the incident light will be taken as negative. Height of the object and height of the image are positive if they are measured upwards from your principal axis and negative if they are measured downwards. The reference is your principal axis. Next question. What do you infer from the experiment which you did to measure object distance and image distance? There is an experiment that has been given and provided in your books in which you take a certain concave mirror and you place a candle, small candle, both at different stands at different distances to each other while they are on a measuring scale. At a certain distance from your candle, you will place a screen, a paper screen, and now you will place your candle at different distances just to measure object distances, image distances, and you will be able to observe what we already discussed through ray diagrams. So what you infer from the experiment were the position of object that you put, that was the candle, and the position of the image of the flame that you got. So to summarize what we did, or what the activity was to make you do, was if the object position of the object when the concave mirror is in front of you is at infinity, position of the image will be at focus. it will be real, inverted, and diminished. If the position of object is beyond center of curvature, then position of image will be between focus and center of curvature. Again, real, inverted, and diminished. If image object is at center of curvature, image is at center of curvature, real, inverted, and same size as that of the object. Between the focus and center of curvature, image is beyond center of curvature, real, inverted, this time it is magnified. If the object you placed exactly at the focus, the image that would form at the screen would actually be so magnified that it wouldn't be able to be seen properly. Real, inverted, magnified. This image would not appear, this particular point where you place your candle that is beyond the focus and between pole and focus, this image usually, as said, appears behind the mirror. It will not appear on the screen, paper screen that you have taken for your experiment, so you will not be able to infer this. But we know that if it is between the pole and focus of the mirror, it appears behind the mirror, virtual, erect, and magnified. Next, these are the numericals now. Find the distance of the image when an object is placed on the principal axis at a distance 10 cm in front of a concave mirror whose radius of curvature is 8 cm. As I told you, the information that is given on the question will help you decide sign convention. Now, you know it is placed in front of concave mirror. Since it is a concave mirror, the focus, center of curvature, all are in front of the mirror. So, and if you were to measure object distance, it will go from pole. The incident light that will come from the object and the distance that we measure will be in opposite directions. Hence, u, that is object distance, will be given a sign of negative, hence minus 10 centimeters. Radius also will be in opposite direction of incident light and hence will be given a sign of minus 8 centimeters. We know that for spherical mirrors with small apertures, we have radius as twice the focal length. Hence, your focal length now becomes minus 4 centimeters. You have u, you have f, you have to calculate v. From the mirror formula, you have 1 by f equal to 1 by v plus 1 by u. So you have 1 by v minus 1 by 10 gives you minus 1 by 4, which gives you 1 by v equal to minus 6 divided by the ratio 10 by 4, which gives you the reciprocal of image distance, which is 3 by 20, or image distance as minus 20 by 3. This tells you that the image formed is also in front of the mirror, since the sign convention is negative and it is a real image. So if the question also asks you what type of image is formed and where it will be formed, you can infer from your image distances and object distances. You see that if the radius of curvature is at 8 and the focus is at 4, your object is beyond center of curvature, it is at 10. Since it is beyond center of curvature, we see at what distance it was formed through your image distance. Next, magnification produced by a mirror is +1. What does it mean? When magnification is +1, it means height of image equal to height of object, because instead of 1, we will have 1 equal to height of h1 or hi by h0. So cross multiplication will give you h0 equal h1, which means that the size of the image is equal to size of object. Plus sign is indicating that image is erect, the plus magnification sign. That is it for this question. Let us go to the next one. If a spherical mirror were not known to human beings, what would be the consequences? Right now, in some sessions, we discussed a lot of uses of convex and concave mirrors and even plane mirrors, to be general. So a lot of daily activities and that we do are make use of lenses and concave convex mirrors. Even technical industries make use of the principle where mirrors are required. Spherical mirrors are used in rear views of mirrors of cars and bikes. Spherical mirrors, they diverge light rays over large areas and they're used as reflectors for street light bulbs. Usually, if you have to examine the back backside of your tooth, the dentist uses mirrors. Now, solar heaters, cookers, they're all manufactured using the principle of concave mirrors. Hence, if spherical mirrors were not known to human beings, all these activities would require a lot of time, energy, and other ways would have to be derived to be able to deal with them, which would be tedious and it would be time consuming and a lot of energy would be lost. So the world as we know of right now would not be as developed in these areas as it is right now. This is all for this answer. It can even be said in this form of a paragraph or in the form of points, or if you can think of your own places where you make use of spherical mirrors, you can add them right here and give explanations as to what would be the consequences. Let us go to the next question. Draw suitable rays which can guess the position of image formed by concave mirrors. They are not asking you to draw images, or they are not asking you to draw objects. They are asking you to draw suitable rays. So now you remember in our previous sessions we discussed 4 types of rays whose behaviors we already know on spherical mirrors. First one, if the ray is incident on the pole directly at an angle, then it will be reflected back at a similar or same angle where your principal axis will act as normal. That is, if there is an angle that is formed between incident ray and principal axis, then the same angle would be formed between reflected ray and principal axis. This happens only when the ray is incident at the pole. Second, if the ray is parallel to your principal axis, after reflection will pass through focus in a concave mirror. Third, if the ray is exactly in the direction of center of curvature, passes through center of curvature, then after reflection it will pass through the same direction, or it will go through the same path where it came from. As you have to show each diagram one by one. Second, this was the third one, and now the last one. If the ray passes through the incident ray passes through the focus of the concave mirror, after reflection, reflected ray will automatically become parallel to your principal axis. All these are behavior of rays by which we can guess position of an image that will be formed by a concave mirror. Let us now go to the next question. Show formation of image with a ray diagram when an object is placed on principal axis of a concave mirror away from center of curvature. Now when it says away from center of curvature, how to guess if it is at infinity or if it is just at a finite distance? In the question it is said that it is still on the principal axis. This will tell you that now we have to find the image diagram where it is beyond center of curvature but still at a finite distance. So the formation of image with a ray diagram when an object is placed on the principal axis of a concave mirror away from center of curvature is the diagram that has been represented in front of you on the right hand side. You take AB, you label all the right points, center of curvature, focus, pole. If you have to label, make the rays meet properly, you see that the image has to be formed between center of curvature and focus. It has to be real, inverted, smaller in size as compared to the object. This is all for this diagram. Let us now go to the next question. If it is asked in the question, you can even after drawing the diagram write the position and the behavior type of image formed right after the diagram. Let us go to the next one. Why do you prefer a convex mirror as a rear view mirror in vehicles? You know that when you place an object either at infinity or even between the distance of infinity and pole, convex mirror will form a very small diminished image of it. So if you have a convex mirror as a rear view mirror, it will cover a larger area that is behind you. So once you get a larger view of the traffic or the vehicles that are behind you, and all they will appear as small diminished images on the convex mirror. This will help you get a view of the traffic behind you. So we prefer a convex mirror as a rear view mirror in vehicles because it gives a wider field of view, which allows the driver to see most of the traffic behind him and prevent accidents. Convex mirrors always form virtual erect diminished images of objects that are placed in front of it. That is it for this question. Let us go to the next one. A convex mirror with a radius of curvature of 3 meter is used as a rear view mirror of a vehicle. Now, if a bus is located at 5 meter from the mirror, you have to find position, nature and size of image. You have radius as 3 meter. We know the aperture is small, so focus will be just half of radius, which will be 3 by 2 meter. Now, since it is a convex mirror, the object distance will still be negative, it will be -5. If you apply the mirror formula, you will get V as 15 by 13 meters, which is 1.15 meter. So imagine just an object which is 5 meters behind your 5 meters in front of your mirror will have a distance, will be formed at a distance of 1.15 meters behind the mirror. Since you have image distance and object distance, you can find magnification. Magnification, if you find, you will be able to describe the size. Now, if you substitute in the ratio minus v by u, you have the height of the image as compared to height of the object is 3 by 13 times the height of the object. So, what you have to say is that the object will form an erect, virtual and diminished image which will have a magnification of 3 by 13 times the height of the object. That is all for this question. Let us now go to the next one. To form an image of the object itself, how should we place the object? Explain with a ray diagram. We only know that there is only one condition when it comes to concave mirror. If you have to form the image that is exactly the size of the object, you have to place the object at center of curvature. As you look at the diagram that has been presented in front of you on the right hand side, there is a ray diagram which represents an object placed at center of curvature. Two rays, one that passes through focus, goes and becomes parallel after reflection. Other incident ray which is parallel after reflection passes through focus. Both of them meet at a point which is directly beneath the foot of the object, and the image formed is exactly the height of the object. Hence, to form the image on the object itself, the object should be kept at center of curvature. You can draw two rays, one of them which is parallel to principal axis and passes through focus after reflection, another which is passing through focus and becomes parallel after reflection. This is all for this question. Let us go to the next one. If an object, okay, so these are multiple choice questions. If an object is placed at center of curvature on the principal axis in front of a concave mirror, we already know position of the image will be exactly at the center of curvature. Next, if we get a diminished image with a concave mirror is placed, it means it is beyond your center of curvature and the image is forming between focus and center of curvature and it is diminished. Next, when we get a virtual image in a concave mirror, the object is placed, there is only one condition where one position where you can place your object where you will get a virtual image produced by a concave mirror. It will be between focus and pole of concave mirror. So between pole and F is the answer, B. Next, which of the following represents magnification? Magnification is represented in two ways, that is height of image by height of object, that is the third option, and negative of height image distance by object distance, that is the second option. So the answer is B, 2 and 3. Let us go to the next question. Ray which seems to be traveling through focus of a convex mirror, path of the reflected ray of an incident will be parallel to the principal axis. As you know, if a ray is passing through focus or appearing to come through focus after reflection becomes parallel to axis. Let's go to the next question. Size of the image formed by convex mirror is always. Size of the image that is always formed by convex mirror is diminished. As we know, if you place the object at infinity or any distance between infinity and pole, image will be formed, will be virtual, it will be behind the mirror, and it will be diminished. Next question. An object is placed at a certain distance on principal axis of a concave mirror. The image is formed at a distance of 30 cm from the mirror. Find the object distance if radius of curvature is r. If radius of curvature is r, then focus is 15 by 2. And if image distance is 30, then you have a concave mirror, image distance is minus 30. So what you take is 1 by v equal to 2 by 15 plus 1 by 30 minus 2 by 15 plus 1 by 30. If you take the LCM of 15 and 30, you get 30, and then if you multiply the 2 above, you get minus 4 plus 1 by 30, which is minus 3 by 30, which is 1 by minus 1 by 10. Hence the image is at 10 centimeters. The whole numerical that I just discussed with you, I will provide the solution in the MS Word document. Next question. All distances related to spherical mirrors will be measured from the pole. It is in the sign convention rules that all distances relating to spherical mirrors are measured from the pole of the mirror. Next question. The minimum distance from a real image to a real object in a concave mirror is. We know that we have seen so many positions of when the object is placed and where the image is formed. We know that an image and an object when placed at center of curvature forms an image directly at center of curvature. So the distance between the foot of the image and foot of the object is actually 0. Hence the minimum distance for a real object from a real image in a concave mirror is 0. That is it for this session and for the exercises of the chapter Reflection of Light from Curved Surfaces. I hope the basics have been clear, and I hope the numericals have also been clear. It is a basic application of the formula. You just have to remember the sign conventions. All the exercises I have discussed will be provided to you in the form of a MS document or PDF format so that you can access them quite easily. Till the next session that we meet, I hope everybody is safe and sound. Thank you and goodbye.